Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
That's right. So with that, we'll get to today's focus incident. We're talking about an Azure Front Door and Azure Content Delivery Network issue that was impacting service management operations for up to 20 hours from the 8th to 9th of April 2025. Now, a key thing to mention here is that this did not impact the ability for Azure Front Door or Content Delivery Network to serve traffic. The impact was really just limited to some service management operations. So we'll talk a little bit more about what that looked like.
Magic. And to talk us through this, the impact and our learnings, I'd like to introduce our engineering specialist, Abhishek, who is Vice President from our Azure Networking Engineering team. Thank you very much for joining us, Abhishek.
Thank you. Thank you, Sami. Thank you, David. Glad to be here. And let's talk about this incident.
Let's crack into it. So, but before we even get to the incident itself, I wanted you to just kind of help frame the problem statement for us here. So could you talk us just a very brief introduction to AFD and CDN, and especially kind of the layering of the management and control plane so that we can understand the characters of the story?
Sure. The name is the Azure Front Door and CDN. This is the application delivery platform where you bring your application, and then these suites of products provide acceleration, load balancing, protection against L7, content caching. So all those the offerings are part of Azure Front Door and then CDN service offering. By nature of this serving the application, this service or both services are global in nature. They are global in nature because customers are bringing their application, www.contoso.com. It's not really tied with any region or anything. So since the entire application domain is getting onboarded to Azure Front Door or to the CDN, it's a global operation on that service. And that brings it to the management operation. So when you do a management operation for a customer, it's not really doing a management operation on a regional part of your application. It's on the application itself. So I have a diagram to go in, the layering of our management plane. So Azure Front Door servicing, it's like any other Azure services. The interaction happens with the Azure portal or CLI or PowerShell or the REST interfaces. Then we have these different offerings as part of the Azure portal that gets plugged into it. So our RP layer, which we call it resource provider layer, that has a separate layer for Azure CDN services, separate layer for the Azure Front Door, and then other services. So at the resource provider layer, though this outage impacted both CDN and Azure Front Door, these are still divided into different resource providers. Then we have internal in the between these resource providers talk to a middleware of database. And this database is where this customer application related configuration that making a change or bringing that profile, this layer is passing it to our database layer, which is a SQL right now. And then this SQL layer is, again, it's locally replicated. So if anything happens into a Azure zone, this could fail over to a local replica. If that entire region is gone, it could fail over to a different region. It's replicated about 7 regions in Azure. So we are well distributed and resilient against any regional zonal failure. But having said that, in this outage, these resiliency failures, or the fire breakers didn't work as expected, and we can dig into more details what happened there.
I'd love to. And if we don't believe in root causes because we know complex systems fail in complex ways.
Yeah.
But we spoke in the PIR about the trigger event.
Right.
And the trigger event here was a lock contention where we had multiple resources competing for a single database. Now, can I understand all these multiple resources? Could we explain it so my mother would be able to understand it, or quite simply so everyone would be?
Yeah, in the common lingo, it's called your database entering into a convoy state. And when this happens, that means lock contention is so bad that the entire database, whatever database it's using, it's not like, specific to SQL. It could happen to Azure Storage. It could happen to your Cosmos DB. But it's, in nutshell, it is the locking contention has built up queue so much, then its ability to clear up in itself, it gets almost zero unless you take a major action to get the system come up. And then the challenge is, since these are the operation in the database itself, all the wire breakers, circuit breakers we had, which is like failover to the other replicas and other geos, they will enter into the same convoy effect by the nature of that, because it's happening in the database itself. So it's not really a contention of CPU. It's not really contention of memory. It's a really contention of a common resource, and that gets to be more into that, like, how your partitioning, like, works for your database, how you design your schema. There are best practices for each of the database layers, right? Like, SQL has its own best practices, Cosmos DB has its own, and in this case, really what happened is, in the SQL, there is a resource called a tempdb resource, which, like, even if you are looking for a different records, different entries, but for each query, it needs to get access to that record. So ultimately, like, thousands of the operations you are doing, and you have that all the CPU and memory power, but you are just logged on that one single resource.
Got it. And I like the way that you explain that, because even for the local replicas, or even for the replicas in other regions,
Correct.
it's the same issue. So
Right.
you can't run away from the problem
Right,
like that.
right.
Got
And
it.
yeah.
There was a really interesting note in the post-incident review that talked about, over months, there was this organic growth in the query workload that ultimately kind of made it more susceptible to lock contention. Is that something that we should have noticed? Is there some kind of AI ops that should have been aware of that, or tracking that? Like, were we caught unawares by that kind of growth?
To be honest, yes, we were just caught a bit surprised. And we'll cover in the discussion what happened in the entire process of the outage. But the part was the convoy effect on the SQL, and then our partitioning is like could lead it to this impact was unknown to us. Having said that, we were following SQL very closely, the overall CPU usage, our query execution time, and then the memory usage, number of queries going into the SQL. And the parameters that we were observing, like, hey, number of queries going up, with the organic growth, the execution times remains pretty much the same, the CPU and memory utilization within the threshold. So those warnings were not there with the organic growth. And when you work on the SQL database, at time to time, over period of, like, a months, your query pattern little bit changes, and you see some regression here and there in the query, and there are, as part of the best practices, you basically put a new query plan, and you get back to on track. So even those monitoring and things we were doing for past many months, but in this case we were totally surprised. And in fact, like, we have the SQL expertise, quite senior distinguished engineer, and then it took them for a while to understand this is what it's happening. But once it's understood, it became like clear what to do and how to manage it. But it was a little difficult.
It's interesting. Abhishek, should we think about this? I know we hate having single points of failure. Is this a single point of failure? Is this something we had registered as a risk to say, hey, if this SQL database runs into issues, we have a problem? Or am I understanding it the right way?
Right, not for this impact, but this SQL could be a single point of failure, not as it's running as a single instance. As I said, it's like well replicated across. But given that for a large distributed service like Azure Front Door, and then we are having a way of our database, it's partitioned into a SQL cluster. We identified, for any reason, if this cluster gets corrupted, which like lock or anything, this could become a single point of failure. And this was identified about 2.5 years ago. Internal process, we have, like, all the risks to our services in future, or like, likelihood of it could happen. This was registered, and we as our engineering team working towards to mitigate this risk registry item. Unfortunately, this incident happened just 3 weeks before, where we were able to complete the transition of this risk to a mitigated state. But
that's always the
that's
way.
always the yes.
We're always going to get unlucky.
Yeah.
That's interesting. Now that we're at the incident itself, could you talk us through kind of how we responded to the incident? I know one of the big things that customers will be thinking, this is 20 hours, almost 20 hours,
Yep.
really long time.
Yep.
But based on what you're saying, we'd already planned for this failure mode. So
Right.
can you talk us through how we detected it, how we investigated it, and then ultimately how we were able to mitigate it?
So detection part, given that management operations, our control plane operations, we have monitoring for each customer success and failures. We call it internally SLIs, and SLIs were monitored for each customer and then application level. So we were able to get a notification or detection that wakes up our on-call or DRI. Actually a 5 minute before the actual impact has started. And the reason is we could get it a 5 minute early warning because we have a certain SLA to complete these management operations across the fleet, and Azure Front Door is deployed across 300 sites globally. So it takes a time to deploy that configuration. But our monitoring caught that the SQL query regression is happening, and then DRI got alerted and joined. Now the question comes that it took 20 hours to mitigate the incident. Initially, when the query regression happened, DRI tried to follow the regular TSG, where in general, with the normal traffic and query pattern changes, query plan regresses, and then let me try submitting a new query plan, and then let's see whether the new query plan would address this situation. So initial try of those regular steps that are part of the TSGs, and in fact part of the well-automated scripts, it didn't work. It didn't work because as I said, it took us as a surprise, that convoy or the lock contention issue. When it didn't work, and then queue was building up, we thought of giving more CPU power just in case, though the CPU utilization remains still pretty reasonable limit. But as a DRI, try to still boost. Maybe these instances are in some bad state. That didn't help. We did a failover to the local replica and replicas. That also didn't help. So it took a little time, and before we could even understand this is serious and this is not what we typically see on our SQL query latency and other challenges. We involved our SQL experts, and those DRIs joined as soon as we basically asked for the assistance. So, and the time why it took a long time, it actually had to go at the memory dump level on the SQL, and then analyzing with the code to say we are in this lock contention and convoy mode. And now with this experience, if next time this happens, we would have this memory saying, oh yeah, this could be. We don't have to go, though there would be no monitor or metric to say we are in this mode, but looking at the symptom, we would be able to know. But it took a long time for just to get, hey, this is in having this the resource contention on the SQL itself, and this took hours.
Just to diagnose the problem.
Yeah, to diagnose the problem.
And then once we understand that that's what the problem is, that we've run into this lock contention, then there's not much you can do other than try to create that breathing room. How do we go about that?
Yeah, and then once you enter into the convoy state, it's not you just reduce some query volume to get systems slowly come back on track. No, it doesn't. You have to just almost give a major breathing room. It's again, we didn't have those the TSGs, automated TSGs to do that. So it took a while, but what we did in that case, we have to move a certain volume of queries away from the SQL instances or SQL cluster. And we had two choices. We serve everything critical on our production. So we had to make a choice between serving our customer management operations versus serving our internal operations like billing. So we stopped to get that breathing room. We stopped billing. We stopped our the query and then stats for our own diagnostic, our own monitoring, and then detection system. So we stopped those, and that gave a little bit breathing room, and it like after a while it recovered. The other part is it recovered little earlier than 20 hours. It's about like 14, 15 hours. It was recovered largely for almost all management operations, except there is a one niche scenario which is linked to the private hub, private link. Since our monitoring was still showing there is a huge latency on that particular operation, though based on our the support tickets and then the critical sits filed by our customers, majority were recovered, but we did declare this mitigated once even that niche scenario was.
I'm sure this is fascinating just to hear about how the lock contention or the convoy state appeared in the first place. The natural instinct for our DRIs to add more resources to it, even though it was ineffective. Probably the most interesting piece is when we're moving we labeled it in the PIR as low pri. I'm learning now is that this was customer billing information, which means we'd rather serve customer traffic than bill customers for it. So we didn't bill customers during that time.
Yes, that is correct. We let it all the billing jobs queued up or stopped for a very, very long time. And we were not sure whether we would be able to even recover, but that was okay. Our management and we were all okay to lose that operations, and as long as we can bring back our customer operations.
The other, this is fascinating. The other piece is, it reminds me of probably an oversimplistic version of a knot. Like once you give it breathing room, the system self-heals.
Yeah.
And it was just about creating that space for the system to catch up and so on. The other piece of changing query patterns on the fly it's an incredible feat from the SQL team, from your own team as well. So learning about that was interesting. As we move over into the repair items, one of the key repair items is we're going to change the queries. I think it was the query patterns we're going to change, or the query load, and we're going to move things off.
Yep.
You mentioned earlier that everything is kind of high priority and important.
Right.
What did we change? What did we move off?
So this is what after this, given in these state, and then to make sure till we go to our North Star or the right way of managing this DB that we talked about in the risk registry, as an immediate mitigation steps, what we did, we created a 2 parallel system, one to take our internal query loads and then other one to take the customer operation. That we could do with the very incremental code change, and then we were very confident that this could roll out safely. So that's the first thing we did. That's the first thing, creating, and that ensuring that we have a major breathing room across both the systems if anything happens in terms of query plan regression or volume increases and all. So that's how we created a major breathing room till we moved to the vNext investment.
Got it. And that's a great kind of follow-up for our next repair item. So we've talked about moving that query load off. We've talked about improving resilience by reducing just the amount of workload that we put on that SQL as the dependent service. But the big one is this kind of new, more efficiently partitioned future database architecture. What does that look like?
So this is where what we realized that our database partitioning, it was partitioned into a different tables and then records, but it was not partitioned at the granularity we want. So in those partitions, if any of the partition gets impacted on SQL, is still that partition or for that record, it was serving a very large number of customers. So one of the things that for past 1.5 years or 2 years, we were working to create a database schema and partitioning that happens per customer level. So imagine the same SQL cluster, which we have as a common cluster available for entire Azure Front Door and CDN. We are having these partitions getting created for individual customers, but still using in a much distributed manner, and then having all the facilities or functionalities that we were having in SQL. So that's one big thing that as a vNext design on our database partitioning and a schema we were investing upon. Migration is a tough thing also. So more than the designing that part, we have seen from our experience when you migrate databases, it's really tricky. It's not the same one's equal to the other. So that's why like the execution on this, we have to be really careful and then execute with keeping the security, safety, and quality top of in mind.
But one of the things that's interesting, I know that in Azure, we tell customers outages are inevitable, that they're going to happen, but we want to characterize outages as they're quite fault isolated and there shouldn't be multiple zones or multiple regions. In this case, we had multiple services impacted because they were sharing the back SQL database.
Yes.
Are there plans to tease that apart, or is that by design? Are there benefits for that?
No, actually, there is a dependency out there. For example, even though there are two different services, but since both services kind of onboard application, what we don't want, a system should not allow to have application onboarded to CDN and application onboarded to Front Door. It's a one application, either you onboard there or you onboard here. And then easy part was like, to having a database that's a database for applications. So these are unique. So they were not like, coming as a CDN or Front Door. This is databases of all the unique applications that our system or platform is serving. But unfortunately, in that case, it's mixed up. And then when it's mixed up, then it impacted both CDN and then the Azure Front Door services. So when we are designing this database partitioning, what we are doing is we are taking Azure Front Door Standard and Premium completely away. So if the same regression happens, it should happen into a customer level partition, and B, it should not have like impact for both the services. It should be either CDN in that case or Azure Front Door.
Cool. Well, that's a great explanation. So I think architecturally, we understand how we're learning, how we're improving from this. But there was one other repair item in the post-incident review that was less about architecture and the system resilience and more about keeping customers informed. So we said there we want to kind of enable more of these auto communications for the scenario. Can you touch on that a little bit?
Yeah, sure. We have on Azure Front Door for both our serving plane and data plane and our control plane operations, the SLA, SLI we provide. If we regress from that, we onboard into the system on Azure system that notifies customers automatically. So Azure Front Door management operations were onboarded to that auto notification systems. The challenge was the metric we have put in to trigger the auto notification to the customers was much on the higher side. And depending upon, given these are not a constant data plane packets, queries coming in, these are the customer operations. So A customer tries, then a point B customer would try, and then C customer. So that's it's a limited set of customers that are trying, and that threshold reached, I think, though we were engaged early on, that threshold reached about 4 to 5 hours in the outage time, and that did auto notify the small set of customers, or not a small set of customers, those set of customers. But that's a repair. We want to make sure, like, and that was a bug, actually. It's not like by design we wanted to have that threshold. That was a bug. So we are fixing that. It's already fixed. And then B, once that system is there, again, when the impact happens and auto communication to the customers happen, but it doesn't stop there. A new customer would be trying when the issue is not mitigated. And that system takes care of even those regressions. So it does, as and when the new customer tries and part the delta or the difference, and then the additional customers would be auto notified, and that's part of the repair. So we will cover the holistic scenario. We do not want a long running outage, but in a worst scenario, a long running outage happens and the newer set of customers get impacted, they would get auto communicated.
But when we think about outages, we tell customers that outages are inevitable. We also learn from these things as well. One of the things we try and do in our PIRs is we tell customers, this is what we're doing to make sure things like this don't happen again. And then we tell customers, here are things that you can do.
Right.
And in this instance, we told customers, hey, if you had a retry logic with the right back off, then you wouldn't have been impacted. And I remember kind of raising an eyebrow to this, saying, is that really the case? Could customers have avoided control plane failures with a retry back-off logic? For me, it seemed like a strange one.
Yeah, this outage, the regression was bad. I mean, the latency time of SQL was gone up to like hours, like, in this case. So to be honest, retry, you have to be extremely lucky on those scenarios that only handful of operations were getting picked, and then like given the large set of customers who were making changes, you to be lucky. So I won't, you are right. I won't say that was a workable workaround that I would recommend saying that retry would work. In that scenario, customers were kind of stuck.
But in practice, it's a good practice to have outside of the scenario,
right.
I guess.
Well, yeah, this is a good practice. I mean, I would say any operation, especially the management operations or connection attempt, having a retry built with a back-off is the right mechanism. Retry is a good thing, but it's a worse thing if you don't have a right back-off. You could create a perfect storm and then let system not able to recover at all with the retry thing. And we have seen with this many outages. So when I ask or suggest customers, I said, make sure we do put emphasis on the right back-off time on your retries, and then ready to give up on retries if it's not successful.
Yeah, that's a good explanation. So like you say, a good best practice to have, but even in this scenario, maybe it wasn't the get out of jail free card we thought.
Yeah. There is another interesting point, and I'll share. This is, I was surprised with the number of customers, and it's an internal term in Azure, we call it crit sit, which is like customers really saying their production is impacted and it's really a critical situation for them. The number of crit sit filed for this incident were high. And I was surprised because in my mind, once your application is onboarded and you're trying to make some changes, and it's a painful thing, those changes are not going through. But as long as your serving plane and data plane working, it should not be a critical situation for you. But what was a learning there, the operations like cache purges, where like they take out those purges, it's a compliance thing. Sometimes you have to take off, and you have to take off immediately. So there were like, more than 60% of customers who are just desperately trying those cache purges. There were customers who were trying to replace their application bad origin with a new one because they were seeing it's not an Azure Front Door data plane problem, but they were seeing problem in their origins that were not able to serve traffic, and they want to move that to a new origin. That was a control plane operation. So it became a sort of data plane or application workload impacting event for some of those.
I find that really interesting because, like you, I think once you've created your instance and it's serving traffic, okay, you can't rename it or delete it, but sure. But you're right, when you think about purging stuff, scaling out, scaling back, like everything goes through the control plane. So you're right, it's so much more than just create and rename.
Yeah, in Azure, with these experience, we treat control plane is as critical as data plane. So that was not I mean, from our response wise and our the effort to mitigate, it was exactly the same as like we would have done with any other data plane outages. But still, it was a good learning to see that we need to be extra careful given customers are taking the compliance, security, and application dependency on these operations.
Right. It's a myth to think, oh, it's just control plane. Just control plane until you can't scale up. That's great to understand. So I've saved my last question for my co-host Sammy here. We've touched on a few of these elements to do with communications, like the autocoms point, but Sammy runs our communications team. And so we always save our last question to say, how did we do in terms of our communications to customers? Do we have any other learnings apart from onboarding that brain scenario?
The onboarding brain scenario is definitely one. And we'll work with Abhishek's team on how to do this. We often think about how we communicate control plane outages. So is a friendly error message better, or is a service health alert or sending a communication better? We tease those apart in general on how we approach things. In this one, it wasn't great for our customers. It took us several hours to get most of the impact because it was dynamic throughout the thing. We didn't really offer an ETA or much workaround. So for the first 2 to 3 hours, our updates were vague. We didn't convey the sense of urgency that was happening in the back end when we're calling in SQL and we're trying to remove this kind of convoy state and this lock contention. We didn't convey that. What's interesting is on our public status page, CDN is listed, CDN and Azure Front Door are listed as, you can see the kind of the regional checks where they're actually global services. And Abhishek spoke about the global nature of these. So even if ARM goes down in an entire region, or if you have a regional outage, it won't affect CDN or Azure Front Door. But we sit down and I think there's a misrepresentation where we need to go and kind of correct that. It looks like we're still running the analysis. It looks like there may have been a slight under-communication. So there are a few customers who may not have received any communication, but could have potentially been impacted by this as well. And again, I think one of the things that we try and do in the communications team is to convey what's going on. This is what we're doing. This isn't working. We've called in the SQL expert, and they're trying to get this lock contention out. And once it's breathing, we hope it can go back. We've shed this data. We didn't convey all those things that are happening. And one of the things that we try and do is we try and let our customers who we're treating as partners, here are all the updates. Here is everything that's happening. And as again, I think there was room for improvement there. We were very vague. Sometimes the workaround we provided didn't really help with management operations either. We're pleased that we can do incidents like this to try and rebuild trust and shed a light on it, because we weren't being opaque. It's just, I think, in the fog of war, getting information from the engineering, putting it in a cohesive way can sometimes be challenging. And we need to do better in there. We are getting better in general, but from a customer lens, if I were a customer, I think we should absolutely be doing better.
Yeah, still room for improvement in terms of being extra transparent, so customers, so the cloud isn't this black box that customers know what's happening. So thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage, and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.